Hello guys, welcome back. I hope you watched the previous video, that is rule-based systems. If you not watched that rule-based systems and you do not have the idea about that rule-based systems, then please watch that video so that you can get some knowledge on it. Now in this video, we'll understood some more detail about statistical NLP models. If we observe this, that is a rule-based systems, then there we actually created some rules. So based on the rules, whatever the input that is provided, the corresponding rule will be executed or the corresponding action will be taken, and that response will get as a response in this rule-based system. In real time, defining each and every rule becomes very difficult, and it is even very complex to create such large rule-based systems in real time. So that's why the evaluation of this statistical NLP model came. Now let's understand how this model will work, or how does this model will actually process the given data. If we provide some data into it to this type of statistical NLP model, then this model actually tries to predict, it will try to predict the relationship between words in a sentence and whole sentence relationships, and this model also predicts the patterns which are provided in the question, whatever the input that we provide to this model. So in that model, in that question, whatever the input that we provide to this model in that question, so what is the patterns, what pattern they are following on the question, and what relations are there in the question, that will be identified in this model, that will be predicted in this model by using some statistical methods. Then after predicting, by using some more advanced statistical methods and probability methods, this will identify or estimate or predict the next upcoming word in the sentence based on the given input. So what is the next upcoming word, that will be predicted by using this statistical NLP model, right? Yes. So let's define this processing. So this is actually input processing, or how the model is working, how the input is processing, or how the model is working. In this statistical NLP, the model will learn the relations and patterns in the input to predict and generate the next word by using probability and advanced statistical methods. So let's take a simple example to understand it. Now, in this example, I want to show you by using probability or statistics, simple probability example I am picking to tell you about this statistical NLP. So here I want to predict the next upcoming word for the given input. Let's say I want to provide the input as NLP and I am expecting the output is. So here first we'll move back to the model, how it will work. This model will work based on the statistical NLP model will work based on statistics and probability. So based on the given input, it will predict whatever the next coming output. So what will be the next coming output? That next coming output probability will be predicted. Based on that, so which word can have high probability, that will be provided as the response. So for this, we need initially to store words with their probabilities. You can see here. So first, I have just imported some dictionary. In this dictionary itself, or you can say in this bigram count dictionary, I want to store the probabilities. And one more point, that is I am predicting the next word based on adjacent two words. Let's say this is my sample data. This is my sample data. If I got I as the current word, then I'll predict the probability of love. That is the next word. The probability of next word will be love is more. And you can see here, if I provide this as well, then I can assume after I enjoy also the probability is there to came. Let's say if I provide NLP as the input, then what is the probability of the next word? The probability of next word must be is, because is will be present 2 times. So that's why the next word will be is. Here, so how actually that probability will be stored? So for this word, so what is the upcoming next word? The next word probability will be saved based on the given data. For storing the next upcoming word and their probabilities in certain variable, here I've created this bigram count. So currently for this demo, I am just picking just 2 words and saving after this word. This is the next word. So like that I am saving. After this word, this is the next word. Like that I am saving the count. So I want to show you that. That's why I'm printing the response as well here, so that you can able to see. In this bigram count, I'm storing the data. You can see, yeah, I'm printing it for the first time, and let me break it after printing for the first time. Now I want to run this. Yeah, you can see. So after first iteration, what happens is only this count will be saved. Only this count will be saved. After I, the predicted value will be low. And after low, the predicted value will be NLP. You can check it here. So after I, the predicted value will be low and their probability is 1. And you can see in the second iteration, it also gathered the information, that is this iteration. After low, the predicted value will be what? NLP, that is this, and the probability is 1. Now like that, so if I move it back and if I remove this break, then I can able to store whole data predictions. So what is the next upcoming word based on the previous word I am saving with their probabilities. Now I'm just rerunning it so that you can able to see all the words and their probabilities. After I, this love will came once and this enjoy also came once. Based on this data, I am what I am doing, I am storing the prediction values of next word. So what is the next word? That next word predictions I have stored in some variable. This method we call as bigram method, because I am storing next to one word only. That is only based on the 2 words, based on the 2 grams. Or let's say if I am storing based on n number of variables, that is based on next n words, then can I say that as n-gram counting. Let's say if I store based on the next 3 words, then I can say it's a trigram counting. Since currently I'm storing based on the continuous 2 words, I can say it as bigram count, right? Yes. So here what I'm doing is simply I'm picking the corpus. That's nothing but this whole data. Then first I'll get this and stored in the sentence. Then second time the sentence will be stored in this variable. Third time the sentence is stored in the sentence variable. Fourth time the sentence will be stored in the sentence variable. Then by using that sentence, I'm just lowering all words and splitting that. That is I'm lowering each and every word and I'm storing them in a list, in the form of a list in this words variable. If you see one sample data, that is I'm printing the words, and now I don't want to see all this data, so that's why I'm just removing this. Now I'm just running this so that you can able to see the words. So how the words will be? I love NLP. So like that, these all words will be splitted. So then after the words will be splitted and stored in this variable, and Now I'm iterating from here till here. That is a total length minus 1. Up to total length minus 1, I'm iterating. And each and every time, what I'm doing for the current variable, for the current word or letter, the next predicted value will be this. So like that, I'm storing the variable count. You can see for I, the next upcoming word will be love. The next upcoming word will be love and storing the probability as 1. And so first time this will be happen. Then in the next time, these two will be taken. For this value, this will be predicted as the next upcoming value. You can see for the love, NLP is predicted as next upcoming value with a probability of 1. So like that, for the whole corpus data that we provide, the probabilities will be saved in this bigram count. So like that, if we provide any word, then based on that word, it will predict the next upcoming word. Or else you can say we storing. So in this way, actually, I'm storing the current word with upcoming next word probability, right? Yes. So I've stored that data, and based on the given input, so I've written one more function that is a predict a next word. And what it will do is it will take whatever the given word, and if there will be any if the next word is not defined, then I'm just returning this none. Of course, this is not required for now. And so if I'm picking the next word, I'm picking the, or you can say sometimes it might happen that is the next word might be not there. That is here in this case, if you see NLP is the word that I provided. So for NLP, do I have some data? Yes. So currently for only this, let's say I trained only with this data. I love NLP. After NLP, do I have any words? No. So in my probability data, or else you can say in this bigrams count, that count won't be there. So during that scenario, none will be printed. You can see none will be printed. So let's remove this printing of words as well, so that we can able to see only the output result. Yeah. Now let's say I have this whole data. Yeah, I have this whole data. And so based on this data, actually my bigrams count will be stored. Now based on this, you can tell me, so what is the next upcoming word of NLP? So based on this, is coming once, and here also is coming once after NLP. So since E is coming twice after NLP, the probability of is that will come after NLP is more. So that's why the predicted output. So here in the next words, what it will print is, it will print the next word with their probabilities. You can see I'm just printing the next word. Then this result also I'm printing. So let's hide this result for some time, so that we can able to see the next word result. You can see in the next word E is coming 2 times. So the probability that is a 2 for this word is. So that's why this is the answer. I'm just expecting to print only that answer. So how I'm getting that? You can see based on the max count of that word, next word, what I'm doing, I'm picking only that next word. Now I'm just printing it. You can see, yeah, is getting, right? I want to remove this so that only, yeah, is printing. Yeah. So let's say if I provide, you can see if I provide I, and let's analyze what I'll get as the response. So I am providing, and let's see what I'm getting the response, none. So the reason why it is getting none. Let's print this next word to see the next word of this based on the given data. So you can see there is a nothing is there based on the next word. So for I, why I am not getting the response? So let's see the data, how it will be stored. So first we are taking each and every word. Then what? Yeah, I think we are converting our sentence into lowercase letters. So that's why for capital I, it is not, it is unable to predict. So let's provide a small I itself and let's check do I get the response or not. Yeah, you can see after I love, for getting this word, the probability is 1. And for getting this word after I, the probability is 1. Since both the probability is same, it was picking the first letter and providing me the response. So either chance will be there. So it was picking the current statistical probability method is picking the latest one. Like this, like this. So what happened here, if you observe, we created some bigram and how we created this based on some sample corpus data or sample data. We created this bigram count, and then based on that, what we are doing based on the probability of next word related to the corpus data that we provided, we are just simply identifying the next coming word based on the probability, and we are predicting that, and we are providing that as the response, right? Yes. So for NLP, is the response. So that's why that is printed. Let's see the, let's comment this. Yeah. So this comes under one of the example of the statistical NLP model. What it is doing, it is predicting the next upcoming word based on what? Based on the probability and statistics. So how we define that probability and statistics of the next coming word? We defined that by using this method, by using this algorithm. The code we written, that is nothing but the algorithm itself. And so based on this data, we are predicting the next word will be this. So like this in real time, we need to train our models with a huge amount of data so that our models can able to predict the next upcoming word or sentence related to our input and provide us the response, appropriate response. So here for an example, we taken bigram count, but in real time we need to take more than 10 or 11 words in a sentence, because if we take appropriate number of words in a sentence, so that the accuracy of response will be more. Let's say I want to predict the next two words. I'll pass the current word and next how many words? Next n words. I'll provide the n value. Let's say it is 2. So based on that, I want to get next n words, right? N words. So in this n words, I want to store the data, that is this 2. I want to get the next n words. Like if I provide NLP, the next 2 words I need to get. So how? For the first time you have seen how ease is generated. Next to one word, how we generate, that we observe. Now let's observe next n words. Like now I am providing 2. So next 2 words, how do we can able to generate? So that's that too very simple. So let's store a result in a empty string, and we need to iterate over 2 times. Let's store the result in an empty string and let's iterate over how many times? I want next n words, right? So I'll iterate over next 10 times for I in range of n words. Since I want a next n words, so that's why I'm iterating over next 10 times. And I'm picking the next word. At last, I want to return the result. Okay. And I want to identify the result each and every time. The next word result I want to identify. So what is the next word? The current result. So at first, what happens? First, whatever the word that I have given, that is NLP. That will be passed to here and result will be empty at that time. So then next 2 times it will iterate. For the first time, bigrams of that word. So bigrams of that NLP is nothing but, so I'll get a ease and the probability. So since ease is there, that will be taken as a result. And next time what happens? Next iteration will be happen because the n words are two. First iteration got completed and the second iteration, I want to pick the next upcoming word. So during this time, what is my current word? My current word is nothing but, so whatever the result that I got now. So this is the current word. That is nothing but is, right? Yeah. So that is the next word. And by using that next word, it will again predict the word and then store the result. So after is, what is the upcoming word? If you observe here, so after is, fun is there and great is there. It will pick the latest one and provide me the next two words. And yeah, so after this sentence, I want to put a gap as well so that those two words won't be merged. I want to provide a gap between next two words, so that's why I provided this. Okay, let's print this. You can see is fun. Now we're getting next two words. So like that, if I provide a 3, then I'll get a next 3 words. After fun, I think no word is there. Yeah, no word is there. So after fun, learning is very funny program. So like that, I want to extend the given, or you can say I want to extend the training data. So that after fun, what is the word that I have program. So that word will get. You can see. So it's a fun program. If I provide input as NLP, then what I'm getting, this our model can able to predict the next 3 words based on the given data and probability, statistics and probability of next upcoming word. It is predicting the output, right? Yes. In that way, in real time, by using this statistical NLP, we can able to analyze, we can able to learn relationships and patterns by using probability and statistics, and we can able to take the input and we can able to again identify the relationships and patterns, and we can able to predict and generate next upcoming words. We can able to predict the next word and generate the word as a result as well in this statistical NLP methods. Here you can see, so whatever the major issue that is here we are manually creating the rules in rule-based systems. But here in statistical NLP, we provided a probability based on the probability and statistics algorithm. We are predicting the next upcoming word. And we defined the probabilities based on the previous data that we are training this model. So based on the data that we train this model with some algorithm like probability and statistics algorithm, advanced algorithm, this model can able to predict the next upcoming words, right? Yes. And in this model, we eliminated the need to define each and every rule-based systems. Here, ambiguity, that issue also overcome in this statistical NLP method. So here we overcome these two problems that we encountered in this rule-based systems. Those are nothing but complexity to define each and every rule for designing a model. So that complexity will be overcome by writing a simple statistical and probability code or ML model code that we return. And ambiguity. This ambiguity also handled, it also handles, this statistical NLP also handles ambiguity by considering word probabilities. Okay, this seems to be good and predicting the responses based on probability. Then what is the issue that we face what is the issue that we face while using the statistical NLP model in real time, sir? So while using the statistical NLP model in real time, we face two issues. So one is sparsity and second one is contextual understanding. So what is sparsity, sir? The sparsity is nothing but it's actually data sparsity. So whenever we provide a word, or you can say whenever we provide a data that is unseen by this model. So unseen word combinations are rarely seen. Unseen or rarely seen word combinations if we provide to this model, then it obviously predict the response, but that prediction goes wrong mostly because that was unseen, or you can say that is seen very less rarely. So that's why it will predict you the response based on the probability, but that prediction may not provide you the correct response. So that's what the issue, one of the major issue that we face while using this statistical NLP. One more thing is, while understanding the user provided context, or while loading the data. So currently I used what type of n-gram? I used what type of n-gram in this example? I used bigram, right? So since I predicting the next word based on the previous word, so since there are two, we call it as bigram. We call it as bigrams. Based on bigrams, we are considering, right? This bigrams will consider how they are considering only one previous word to predict the next word. To generate the sentence or to predict next word, it was considering only the just previous word. If I take 3 gram, that is a trigram, it will consider only the previous two words for picking the or generating the next word. If we generate the next word based on the previous one word or previous two words, then it leads to a very huge irrelevant responses sometime, and even contextual understanding of the whole user provided sentences also not possible. The input understanding is also not possible in real time. For this current demo, I have just shown you a sample example of bigram statistical NLP model for you to understand how statistical NLP models will look like. But in real time, if we use such bigram NLP models, statistical NLP models, or trigram statistical NLP models, then we might face these issues. That is data sparsity, contextual understanding. So these are the major issues that we face while using these statistical NLP models. Not only those two n-gram models, you can pick any model. There you face these issues in statistical NLP model utilization in real time. So to overcome the limitations that we encountered while using this rule-based systems, we picked this statistical NLP. But now also we are getting some limitations like long range dependencies and a deep semantic meaning, which leads to adoption of one more advanced NLP method or evolution of one more new NLP era. That is nothing but ML. What is that? ML, machine learning. So in this era, so this is a revolutionized era, that is ML. Even the statistical NLP is revolutionized compared to this rule-based. At starting, this rule-based systems are revolutionized. After these rule-based systems, these statistical NLP becomes revolutionary. And after this statistical NLP, these ML models now become revolutionary or revolutionize the whole era. So in this, we overcome the issues that we face in statistical NLP models. So I hope you understood this video and you understood some more detail about statistical NLP model. and the model evaluation requirement, and the model how it will work, how input processing or model working will happen, and what are the major issues that we face while using this model. And we have also observed this model with some real-time example, that is a real-time code as an example. And we have also understood what is the next upcoming era, or you can say NLP method that came as an advance to this statistical NLP method to overcome the issues that we are facing while using this statistical NLP method. So I hope this video is useful. If you feel this video is useful to understand this statistical NLP model, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. In the next video, we'll discuss about ML model or ML based models. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.